on, external variables. And I'm going to say easy. It's not easy to do, but it's easy enough to do when you control the entire environment. It gets a little bit trickier when you start thinking about third-party data. And what I mean by that is, let's say we're doing a transaction that involves FX rates. If we go to an FX rates provider like Bloomberg and say, what's the Canadian dollar worth against the US dollar? And we make this exchange. If tomorrow we want to validate that transaction and we check that FX rate again, and the FX rate for whatever reason is slightly different because it's coming from a source that's outside of the ledger, we have a problem because we've unvalidated a transaction that otherwise should be valid because data has changed in a non-deterministic fashion. So what oracles enable us to do is oracles enable us to inject data into the ledger in a way that's deterministic. So instead of just saying, hey, Bloomberg, what's the FX rate? And then constantly checking the FX rate every time we validate a transaction, what we'll actually do is we'll ask Bloomberg to insert data onto the ledger in a deterministic way, sign it and seal it so that we have some proof of authenticity of that data. And then from that point on, when we check that transaction, 100 steps in the future, 100 years in the future, whatever result we get to on the validation of that step, we will always get to, because all of the variables in our computation are entirely deterministic. Okay, next, Corda implements observer nodes to enable regulation and compliance. So this is an interesting one, and it's super valuable for us in a lot of the projects that we work on. What's an observer node? An observer node essentially is a node that's kind of like a read-only node. So it's not an active node in the transaction. What an observer node can do is it can sit on the ledger, and based on certain rules, it can determine what it sees and when it sees it. So a good example of that would be, again, I'll take an example from like the payments systems. You could say, I want to see, I want my observer node to observe every payment that is above, X amount of money, okay, $100,000, let's say. So that would be a rule that would be what it sees, when it sees something, and then what it sees could also be determined based on, you could say, I don't want to see the entire transaction for privacy reasons. I don't want to see the sender and the recipient and all their details. I just want to see the location of the recipient, for example. So now you've implemented an observer node that sits in the middle of your network that ultimately can view every transaction that happens, the recipient of every transaction that happens over $100,000. For example. And what this really enables you to do is it enables you to take, a lot of the business cases that we work on. There's a lot of audit and compliance that needs to be done. There's a lot of regulatory requirements. And what this does is it takes the auditing feature that's usually very error prone and behind the scenes to something that happens a little bit more in the middle and in real time. I'm getting a question here. Point 2 says only participants have copies of the data. How can observers have access to the data? So observers don't have access to the data. You can think of observers as almost like a webhook, or if you know Java, of like observable methods. So the idea would be to say, it's built into the application itself. So when you give participants the application and you say, this is a peer-to-peer communication protocol, anybody you interact with, the messages go entirely between the two counterparties, with these observer requirements built in. If you create a transaction between counterparty A and counterparty B that has a value of more than $100,000, the recipient is going to be reported to this observer node. The observer is it's like a listener onto all the transactions that only gets triggered if it meets certain criteria. So this isn't something that's happening behind the scenes. This is something that all of the business participants are aware of and can see the rules of all the observer nodes that were built into the system by whoever is the business network operator or whoever builds the Corda application. So the communication protocol is entirely private, with a hook that says, if you hit these certain filter criteria, guess this part of your transaction is going to get pulled out and sent to an observer, right? Now you raise an interesting point, because just the notion here is like, if you ship a business network and you say, I'm going to let you guys all transact in privacy and completely peer-to-peer, but guess what? Everything you do gets pushed to an observer node, and I see every transaction and every detail of every transaction. Well, there's a good chance that no one's going to use your business network, right? No one's going to use your application, because you're imposing this complete, completely kind of totalitarian observer mechanism. And these are things that business network operators or business network builders or people that build Cord apps for specific ecosystems need to think of very carefully about before they, build their Cord apps, or when they build their Cord apps. But that's a good question. Thank you. I can tell that some people are listening. That's wonderful. Next one. So Corda uses a doorman service or an identity service provider to add entities onto the network safely. So what does that mean? I started by saying Corda is a private permission network. So what that really enables you to do is you have two mechanisms. You have something called a network map, which is effectively the map of the network that if you're on that network map, you can see other people and be seen yourself. And if you're not, you can't. And the identity service or the doorman service is ultimately the system that adds entities onto that network map. When you go to the doorman service, you basically go to the doorman service and say, hey, this is who I am, and this is the type of actor that I want to be on the ledger. So not every actor on the ledger has permission to do every type of transaction. And what I mean by that is, you could think about, again, I'll take a payments example. The Bank of Canada would have different access to different transactions than the regular banks, let's say, right? And an example that would be the Bank of Canada would be able to issue currencies, whereas all the other banks would just be able to move them around, right? So when the Bank of Canada would go to join the network, the Bank of Canada would say, I'm the Bank of Canada and this is proof. And the permissions that I want or the type of player that I want to be is a central bank. Whereas the other banks would say, I am, RBC or TD or BMO Scotia, and I want to be a retail wholesale bank, for example. I've got another question here. Can a BNO have participants that do not have their own identity shared? Say a real estate business wants to share a single identity for many realtors. Is this possible? That is possible. The nuance here is that if a real estate business wants to share a single business identity for many realtors, as far as the business network is concerned, that real estate business, the one that has a legal entity on the Corda ledger, is the actor on behalf of all the other actors, right? It's very similar to, if I send somebody money that isn't in my bank, for example, I'm not really sending, if I want to send money to my friend, and my friend, I bank at RBC and my friend banks at TD, when I pay my friend, I'm not really paying my friend, it's RBC that's paying TD, but they're doing it on my behalf, right? So I would kind of put that in a similar bucket, right? You can absolutely act on behalf of a broader group of people on Ledger, but when you think about the Cord app application and you think about the management of the assets, Corda would have no way of knowing if you're acting on behalf of yourself or if you're actually acting on behalf of 10 smaller businesses that are all underneath you. So these are not differentiated within the vault. Follow-up question to that. The question is, are these differentiated within the vault? The answer is that they could be. You could very much in your own vault add attributes to say, oh, this asset belongs to Joe, this asset belongs to Bob. From Corda's perspective, it wouldn't care who's Joe and who's Bob. Those aren't real entities as far as Corda's concerned. Those are just strings that are attributes of a certain state. Okay, hopefully that makes sense. Moving right along. Last one. So Corda is based on an existing. Yeah, I got a yes. That makes sense. Great. Corda is based on an existing technology that runs in a JVM. So when everything is said and done, when you break Corda into smaller components and you actually look at the technology that underpins all of Corda, all of the technology aspects of Corda are all established enterprise-grade technology components. So Corda is written in a JVM. You can write Corda applications in Java or in Kotlin. It runs on top of SQL-based databases, so you don't need to rethink about how you're storing all your persistent data. The messaging queue is AMQP over TLS. So all of the components that people today are writing enterprise architecture in is kind of what Corda is based on. This really has two impactful implications. The first one is that when you want to build applications on Corda, there's usually a lot of people that have touched and built with these tools, and there's a high proficiency with these tools already, so you can get started building with Corda very, very quickly. The other one is that when you actually want to put these systems into production, a lot of these regulated enterprise grade companies have a lot of tests that they do before you can actually run something in a production setting. It is very, very helpful if they are already running production applications using the technologies that you've built on, right? You can imagine going to a bank or going to a government organization or going to a stock exchange or going to a hospital and saying, hey, here's this new piece of thing that I built on this technology that you've never heard of, that you're not running within your organization yet. There's that much more friction, and it's that much more of an uphill battle to actually implement your solution. Okay, so moving right along. It's going to have that red line in here. I don't know what that's from. So if you think about the ledger from each point of view's perspective, you can kind of think about it like this. So here we have the actors themselves, Alice, Bob, Carl, Demi, and Ed. And if you think about these kind of little colorful circles, every colorful circle is its own little piece of data. And these pieces of data are shared depending on who participates in each transaction. So you can see here that Alice knows about pieces of data 1 and 7. Bob knows about pieces of data 1, 7, 5, and 6. Carl's pretty popular, so he's sharing data with Bob and Ed and Demi, and so on and so forth. So this is the notion of a subjective ledger. I'm getting a question here. Ledgers are not identical in Corda due to the nature of not grouping unrelated transactions. If this is a correct statement, having different ledgers doesn't violate the blockchain concept. Well, I don't know exactly what you mean by blockchain concept, but I would say that what you probably mean is to have a single block that's replicated all over the place. And if that's what constitutes a blockchain violation, then my answer is yes. With that said, though, I would say that a blockchain concept is really, the concept of blockchain is providing consensus and immutability and provenance for digital transactions, right? Immutability, consensus, and provenance for digital transactions. So it's putting value onto a distributed network. And if you think about that as the core value proposition of what blockchain means, then to have a single block that's replicated all over is an implementation of supporting the features of consensus, provenance, and immutability. Okay, so Corda's implementation is completely different than replicating one block of data across everybody to enable consensus, provenance, and uniqueness. I hope that makes sense. Moving on. So I spoke a little bit about Corda primitives. Okay, great. I spoke a little bit about Corda primitives. I think it's just interesting to kind of break it down into these 4 components. And these 4 components really, if you understand these 4 components, you're ready to start building business logic on top of Corda. So states are immutable objects that represent facts. They could be shared if you want them to be shared. They could also be private if you don't share them. These facts could be financial agreements, contracts, whatever. They are a fact in a point of time. Okay. Contracts, we already mentioned. Contracts control the evolution of states by allowing relevant participants to check for transactions validity, for transaction validity. Okay. So states are the objects themselves. Contracts are the things that govern how these states are allowed to evolve. Transactions are this kind of grouping of states and contracts that consume the input states, they create the output states, and the newly created output states are effectively kind of the state of that state on the ledger. Okay. Flows are lightweight processes used to coordinate interactions required for peers to create and agree on transactions. So if you take these 4 things together, states, contracts, transactions, and flows, and you put them all together, what does this actually look like? It looks something like this. So if you wanted to create a transaction proposal, you can see here I have input states, commands, and output states. I would have my input states on my left-hand side. I would add the input states as necessary. I would add output states as necessary. I would add commands, a timestamp if I wanted to, attachments if I wanted to, and the transaction proposal is now ready for signing and verification by all the required peers. So what does this mean? Let's just spend a minute just breaking this down. So what you have here in the large gray box is what we call a transaction. And you can think of the transaction as an atomic unit of change. So the transaction can't be broken down. This transaction either runs and updates the ledger entirely or doesn't run at all. And the transaction is made of input states, commands, and output states. So now if you look just at, let's say, the top part here, what we have here is the input state is actually a null state. The command is the create command. The participants on this command or the required signers or validators on this command are Alice and Bob. And what gets created from this create command is something that we call an IOU. And it's actually a literal notion of Alice owes Bob 10 pounds. So it's an IOU state. So we can see here that this create command, if it gets valid, will mark this state as historic, although there's no state to mark here as historic, but it will create the IOU state from Alice to Bob for the amount of 10 pounds. In addition to that, we could also do something that looks like this. We could have a cash state that's owner is Alice and the amount is 10 pounds. And using a pay command, we can send this cash state or create a new cash state that exists that has the owner as Bob and the amount is 10 pounds. Now, the interesting thing happens when we combine these two commands into one atomic transaction. So all at once, what we're going to be doing is we're going to be moving 10 pounds of cash from Alice's ownership to Bob's ownership. And then we're going to create an IOU from Alice to Bob for the amount of 10 pounds. So this transaction, here we can see our states that we mentioned in the previous slide. So input states and output states. We have our commands that we mentioned in the previous slide. We have our transaction, that is the big gray box that kind of wraps it. It's kind of like the envelope that you put all this stuff in. And the flow is, I think of the flow as kind of like the postal service. The flow is the thing that you use to submit this that will look at the transaction and say, who do I need to collect the signatures from, and which notary do I need to go to in order to ultimately validate this transaction and update it to the ledger. So that's states, commands, transactions, and flows kind of all put together as one unit. I know we only have, just looking at the clock here super quick, we have 9 minutes left. So I'm gonna skip some stuff here. So we talked about verification consensus and uniqueness consensus. Let's jump quickly to Corda Enterprise. Okay, so Corda Enterprise is a commercial distribution of Corda software specifically optimized to meet the demands of modern business. So what does that really mean? I mean, in a picture, I would say that it looks like this. So everything that we talked about up until now was all inside Corda open source. So Corda open source is the core of Corda. You can go to GitHub right now, type in Corda, you'll find the open source version of Corda, download it, you can start building on it immediately. Corda open source is everything that you build on open source, you can run on Enterprise. What does Enterprise give you that you don't get in Corda open source? What it gives you is really tools to run Corda in a production enterprise environment. And what does that mean? It means all the non-functional components of Corda. So everything that you need to have high availability and disaster recovery, firewalls, management support, certain compatibility aspects, engineering, 24/7 engineering support, things of that nature, more database integrations, things like that are things that come as a part of the Corda Enterprise package. Okay, there's a little bit more information here. So like I said, firewalls, some compatibility, SQL Server, some performance enhancements, things of that nature all come within the Corda Enterprise package. So what happens kind of effectively is a lot of organizations will start out on Corda open source, build almost the entire thing on Corda open source, and when they're ready for production, they'll start talking about moving a Corda open source project to a Corda Enterprise project. Now, what's interesting here is that Corda open source actually interoperates completely with Corda Enterprise. So you can have a network where some participants are running Corda open source because they're smaller businesses, and some of the larger businesses maybe are running Corda enterprise because they need the scale or the volume or the support or the database integrations or one of the kind of enterprisey features. We have a little kind of side-by-side comparison, Corda, Ethereum, Fabric, that I think is interesting, but I think the most interesting thing to talk about in the time that we have left is the Corda and interoperability. So interoperability gets thrown around a lot in the blockchain space, and what interoperability means is the ability for different networks to interoperate. A lot of people talk about cross-ledger interoperability, and what that means is different ledgers, Bitcoin, Ethereum, Fabric, Quorum, Corda, all talking to each other, and there's a lot of work being done in that space. I think our position, broadly speaking, is that inter-platform interoperability, in other words, the ability for two applications written on the same platform to talk to each other, is a precursor to inter-platform interoperability. So the idea that two applications built on Fabric or on Quorum or on DA can talk to each other first is a prerequisite to Fabric talking to Corda. And that's kind of the approach that we've taken. So if you think about it, the Bitcoin and Ethereum world was this notion of, we're going to build one public blockchain for everybody, and everybody's going to be able to run on top of it, and everything's going to be great. And I think that the vision was awesome, but at the end of the day, it kind of fell a little bit short, just because it is very hard to create governance rules around a single business network that will run every single type of application in the world. As a consequence of that, we saw kind of like the second generation Fabric, DA, Quorum, where it was all private networks. The problem with that is that all of these networks get completely isolated. So if you build two different solutions in Quorum, they actually have no way of talking to each other, which is, it creates these kind of like siloed business networks that become kind of trapped and unable to talk to each other, even if they're written in using the same technology. With Corda, what we've done is we've created a way that you can have private business networks that can all interoperate with each other if you want to do so. In other words, this node here can be part of all three different private business networks all at the same time, just by the fact that it is a member of all three private business networks. So with Corda, interoperability within the platform across different applications comes completely out of the box. What does this actually mean in practice? What it means in practice is, if you want to send a payment on one business application, but you want to check the identity of the recipient on a different business network application, and at the same time you want to trigger an obligation that is a transfer of title for a piece of land based on the payment, and the payment is based on the KYC, know your customer, AML, anti-money laundering lookup, all those business networks can be private. They can all be run on Corda, but the fact that you are a common entity in all those business networks, you can connect the business logic between all of them to create one overall kind of transactional flow. And that's a very, very powerful notion. So that's something that with Corda, we spend a lot of time thinking about. And I think we've kind of struck a great balance here with having private business networks that all have the ability to interoperate. With that said, there are projects in flight building cross-platform interoperable components. I think about this very much as like building bridges, and these bridges get built if there is a specific reason for a specific use case. And we've done some work building bridges between Quorum and Corda, and some stuff between Ethereum and Corda and Fabric and Corda and stuff like that, but they're very, very particular use cases. This looks kind of something like this. You can see this is another way of thinking about it. So, the broker here would be part of Business Network 1, would also be part of Business Network 2. There's underpinning something called the Corda compatibility zone, but we don't really have a ton of time to dig into that. Very quickly, I'll stop. I'll end with this. Actually, I'll show this slide in one more. So we have kind of Corda open source in the middle, Corda enterprise wrapping around it, and then the R3 ecosystem that we've talked about. We have our members, all of the different people that we would call clients or end users. Delivery partners are people that are building on top of Corda, and in many ways also building applications specifically for this group over here. Infrastructure technology partners, so cloud, hosting, Oracle, not Oracle the company, but Oracle as in injecting third-party data into the ledger type Oracle, infrastructure tech providers, and then Corda app providers. So these would be companies that build applications on Corda and go and take them to market. Finastra does syndicated loans, Tradewin does gold digitalization of gold, Voltron or Marco Polo or trade finance platforms, so on and so forth. You can go to marketplace, r3.marketplace, to see more of this body of work and things that are publicly accessible. And last but not least, I have 2 more minutes. I'll just show you some of the verticals that we're working on. So, there's a lot of focus, and we're kind of came out of the financial sector, but you can see energy, insurance, tokens, government, business, education, healthcare, trade, telcos, technology, capital markets, identity, real estate, and media are all kind of fall within the wheelhouse of some of the projects that we're building on Corda. I have a question here. Is there any work done to bridge permissioned and permissionless blockchains? Absolutely. I mean, the interoperability play, I would say, doesn't really distinguish between permissioned and permissionless, although at the end of the day, you need to be very careful with what's the right way to put it? If you are adding permissionless featured onto a permissioned blockchain, whatever business networks you're bridging between, it's kind of like the lowest barrier of entry will ultimately determine how permissioned or how permissionless a blockchain solution would be. So things like that are just considerations when you do that kind of work. I will pause there. I think it's exactly 1 o'clock. Happy to keep going for a couple minutes if anybody has any questions, or I'll pass back to you.
Thank you so much, Daniel. It was very informative, and I think it's very beneficial for people who want to basically see what are different platform out there and choose the platform that basically suits their use case, right? So we're going to share this video with all of our participants. Also, feel free to join our meetup page and also our public Slack channel. You can find it on Blockchain Hub website, the blockchainhub.org. I think it is it. There's no other questions, but probably they can connect with you, right, Daniel? Is there any?
Absolutely. So my email is daniel.edan at r3. So exactly just my name. You can feel free to add me on LinkedIn as well. There's also a Corda public Slack that you guys can ask questions on. I believe it's called Corda Ledger is the public Slack, and you can just add yourselves to there, and there's general announcements, boot camps. There's a thread for technical questions, and I'm on there every once in a while as well.
Thank you so much, and thank you for your time. Have a great Thursday, and see you soon.
Great. Thanks for having me, guys.
Bye.
Bye-bye.